Okay, my students. So now we are going just to continue what we were talking about diffusion before the meeting is. So as I told you, diffusion is related to matter in the liquid in the gas state. Sorry. So diffusion is phenomena happening to the matter in the gas state. So what will happen? The movement of matter from high concentration to a low concentration will happen. Okay. So if you have a high degree of or highly concentrated matter in the gas state, particles will start to move from the from from high concentration to low concentration. Okay, means but matter is going to be distributed all over the place. Okay, instead of just being concentrated at a certain position, they are going to be distributed in all directions equally. Okay, so we call this the movement of matter from high concentration to low concentration as diffusion. Okay, and diffusion is just a phenomena related to uh, gas state. It can happen. It can happen in liquid state, but it can't be happen by any way in the solid state because particles in the solid state. Remember, particles in the solid state are highly connected with each other. Okay, so they have no ability to move freely in all directions. Okay, so diffusion is something related to the gas state. Okay. Do you have any question about this? Do you have any question about this? Do you have any question about this? Hur?
Mister, and this diffusion thing is in the yellow area, and we are not supposed to take it.
What? Yeah, just this is a general idea about diffusion. Hur. We are not going just to understand because this is a concept related to the gas state. So this is something to understand about the behavior of matter in the gas state. Okay.
So we are not supposed to study it, صح?
Okay, just take a very general idea about this, but don't care about this. Okay.
Okay, thanks.
You're welcome. Okay, yet.
Mr. Can diffusion be between water?
Yeah, I told you, diffusion is highly connected with matter in the gas state because matter in the gas state, particles are have a very big degree of freedom. They can move freely in all directions. But when it comes to liquid state, sometimes it happens, but not a very general phenomena for matter in the liquid state. But it's highly related to connected to the behavior of matter in the gas state. Okay. Do you have any other questions? Do you have any other questions? Do you have any question at all general about this topic today? Okay, we are going to watch this video about the topic of...
In this video, we're going to look at the three states of matter: solid, liquid, and gas, and see how substances can change from one state to another. To do this, we're going to use a model called particle theory, or sometimes kinetic theory, which helps us explain how the particles in each state behave, by considering each of the particles as a small, solid, inelastic sphere. In solids, there are strong forces of attraction between the particles, which holds them all close together in a fixed position to form a regular lattice structure. And because the particles are fixed, the overall substance keeps a definite shape and so it can't flow like a liquid. The particles can vibrate around though, so you can imagine them constantly jostling against one another. Now, if we heat up, these particles gain more energy and start to vibrate, which weakens the forces. And at a certain temperature, which we call the melting point, the particles will have enough energy to break free of their bonds, and so the solid melts into the liquid. In liquids, there are only weak forces of attraction between the particles, so they're free to move around and are arranged pretty randomly. However, the weak forces of attraction do mean that the particles means they have a definite volume, even though their overall shape can change, allowing them to flow to fit a particular container. If we then heat up our liquid, in this video we're going to look at the three states of matter: solid, liquid, and gas, and see how substances can change from one state to another. To do this, we're going to use a model called particle theory, or sometimes kinetic theory, which helps us explain how the particles in each state behave, by considering each of the particles as a small, solid, inelastic sphere. In solids, there are strong forces of attraction between the particles, which holds them all close together in a fixed position to form a regular lattice structure. And because the particles are fixed, the overall substance keeps a definite shape and volume, so can't flow like a liquid. The particles can vibrate around though, so you can imagine them constantly jostling against one another. Now, if we heat up a solid, its particles gain more energy and start to vibrate even more, which weakens the forces between them. And at a certain temperature, which we call the melting point, the particles will have enough energy to break free of their bonds, and so the solid melts into a liquid. In liquids, there are only weak forces of attraction between the particles, so they're free to move around and are arranged pretty randomly. However, the weak forces of attraction do mean that the particles tend to stick together and are fairly compact. This means that they have a definite volume, even though their overall shape can change, allowing them to flow to fit a particular container. If we then heat up our liquid, the particles will again gain more energy, and this will make the particles move around faster, which weakens the forces holding the particles together. Then, once we reach the boiling point, the particles will have enough energy to break the bonds altogether, and so the liquid boils or evaporates into a gas. In gases, the force of attraction between the different particles is very weak, so they're basically free to move around by themselves. This means that gases don't keep a definite shape or volume, and instead will always fill a container, as they spread out as much as possible. Now, we normally say that gases are constantly moving with random motion, which is a bit confusing because gas particles actually move in straight lines. They don't randomly swerve. What we really mean by random motion is that the particles can travel in any direction, and they'll end up being deflected by solid walls and other gas particles randomly. When we heat up a gas and the particles get more energy, and so travel faster, the gas will either expand if the container it's in is expandable, like a balloon, or if the container is fixed, then the pressure will just increase. On the other hand, if we cool the gas down enough, then the particles won't have enough energy to overcome those forces of attraction between them, and so bonds will start to form between the particles, condensing the gas into a liquid. As we cool down the liquid even further, the same thing happens. The particles won't have enough energy to overcome the attraction between the molecules. And this time, even more bonds form, fixing the particles in place and freezing the liquid into a solid. Now, the last thing we need to mention is that if we're working within a closed system, changes in state won't change the mass at all, as there's still the same number of particles. However, the density of the substance will change, with solids having the highest density, liquids having slightly lower density, and gases having the lowest density of all three. That's everything for today's video. So if you enjoyed it, then do give us a like and subscribe, and hopefully we'll see you soon.
Okay, my student, I hope you have understood this lesson, and see you next okay, see you next time. Okay, have a nice day.